Hello, everybody. So my name is Yuri, and I'm gonna talk about metaprogramming Erlang with Elixir. So how many of you are actually familiar with Elixir's ideas at all, or you just heard about it somewhere and you decided to come over for the talk? So just a few of you. Well, it's the one question, basically. Any familiarity with Elixir at all? Okay, some. All right. Okay, so how many of you didn't know Rich Hickey? A little bit more. Okay, so basically this is the quote that he said somewhere, and I stole it from somebody else. Yeah, basically Lisp traditionally really they empower developers because you can eliminate anything that is tedious through macros, and that is the power that really is what people keep going back for. So what is metaprogramming? In a very practical sense. My understanding of it, it's a program that writes program. It's as simple as that. So some practical examples of that would include domain-specific languages. So you can build a language that specifically addresses the domain that you're working in and can be very specific about those details, and you don't spend too much time in underlying language trying to express more complex paradigms. Another one would be embedded databases. So for example, MIME types, Unicode, and any other kind of protocol descriptions or format descriptions that you can embed in your code and use it right from the compiled file. Another one could be conditional compilation. So if there is any ability in the language to compile your stuff differently compared to, dependent on some parameters. Even in Erlang, you can do that with, say, ifdef. So if something is defined during compile time, it will compile one version of the code. Otherwise, it will compile the other version of the code. So that is a code that writes code in a way. Generating a code that dispatches things like requests, for example. There was actually a very good example of that done by Joseph Valim, by the author of Elixir. You can generate a very efficient code if you know all the routes that you have for your requests. You can produce tons of code that will very efficiently dispatch your routes. And precompiled templates. So you have, say, for an HTML template with all the logic inside of it. And instead of interpreting it every time you need to render it, you compile it to a program, and it executes as a real program instead during runtime. So here's the Unicode database example. Python actually does that kind of meta programming where they generate C code from Python. And this is just a tiny part of that implementation. So they take the Unicode database and produce tons of C code that is an efficient implementation of Unicode. So they can do lookups in the Unicode database this way. And here's, again, a small part of Unicode database in Elixir, but it's about probably 25% of the whole implementation that we have in Elixir. All it does, basically, it embeds all the graphemes, all the code points, and other data from Unicode databases in Elixir code. But unlike in Python, it doesn't generate a code by writing strings. It actually generates code from within itself during the compilation process. But anyway, let's make it easier and start from the very beginning. So here's a very simple code in Elixir. So any takes how this will work. What does this code do? Anybody? So here's the output. So when you try to compile it, it will actually print out the first string during compilation time. And here you can see it's what you had on the module level. And when you execute hello.world, well, you will get the hello.world outputs that we defined in that function called world. So basically that means you can actually have code that is executed compile time while you're compiling your program. So how does it actually work? So the main difference here is that unlike in Erlang, every everything in Elixir is an expression. So in Erlang, for example, you would have a module definition for, so you have attributes like module, export, and then you have a syntax to define functions, so say a world function and any other function. But in that syntax, you cannot insert any other Erlang code at the module level. It's just not possible. The parser will not work that way, or the compiler will not work that way. So yeah, you can't really do that. It is, though, technically possible, but you'll be really sorry for trying to do that, because the parse transform monsters will really come and get you. And I know this because I actually wrote a bunch of libraries in Erlang that were using parse transform techniques to enable some interesting things. But that is the most horrible experience I had manipulating my own code. So with this technique, is that enough actually to have another language just to enable this technique? Probably not. Otherwise, we could have just wrote a library or a tool for Erlang that would take another form of Erlang sources and just evaluate them and run those compile time operations. That would probably be just enough. But what Elixir is really great about, it actually has a macro system. How many of you are familiar with any kind of Lisp, say Common Lisp, Clojure, anything like that? Okay, so about a half, I guess. So a macro it basically is a function that will generate code instead of being executed in runtime. So it's a function that you execute compile time, and you get that function to produce an actual syntax tree that will be injected into that piece of code where you call that macro from. And for those who are familiar with Lisp, they will find themselves almost at home with quote, unquote, and unquote splicing techniques. So here's a very simple example. Even though Elixir has its own implementation of the unless construct, here we're just using it as a good example. So what we have is this structure. Can you see this? I hope so. So it says, if not available, do something and end it. And it looks like a regular construct. But now what we can do, we can say def macro unless, and take two arguments. One will be condition, and one will be the rest, basically. And here we say, within this quote, we basically transform this to if not, and here we're inserting the condition, as an actual source tree instead of the evaluation. And here we're inserting all the options that are the same as in the if construct. So this way, we can actually have an unless construct that looks indistinguishably from the if construct. So we just extended the language with something that looks very natural. It's not different from anything else. And this is actually how we implement unless macro. It's just a little bit more complex in the actual library, but it looks the very same way anything else does. So what does enable this? So one of the important things in Elixir, unlike in Erlang, is that all AST nodes, so abstract syntax tree nodes, are actually very uniform. They're always tuples of 3. So the first one will be a name. The second one would be a meta information about that part of the tree. So usually that would be a line number and maybe some other arguments depending on some details and arguments. Let me give you some examples. So here is the 1 + 1 expression. It actually gets compiled into, you can actually think about it as plus function and 2 arguments, 1 and 1. Here is a little bit more complex example. So it's the AST representation of Erlang's I/O format. Hello? And here you can see it actually consists of 2 tuples of 3. So that will be the first one. It has a name of dot, and then it says I/O format. So it basically connects the module name and the function name. Then we again have meta information, and then we have the argument to I/O format itself. being just right down there. And it's easy to explore how those trees actually look. If you start IX, which is Elixir shell, you can just do quote do 1 + 1, and you'll see the actual way it's represented internally. So you can actually play with it whenever you don't really know how it will look like. You can actually just test it very quickly. So why don't we need them again? Because they eliminate anything that is tedious. Great, but now what? Elixir is not just macros for Erlang. It actually turned out to be a great jar of other goodies. So one of them are, so let me actually list them first, and then I'll explain a little bit more about every feature in detail. So we have protocols. It's a way to define interfaces to different implementations. We have a more uniform, thought-out standard library comparing to Erlang's. We have what we call a first-class shell that is able to do a lot more things than Erlang shell. We support Unicode in a much better way. So we actually support graphemes, upcase, downcase, correct length, everything that is related to that, and obviously more. And at the same time, it's still the very same Erlang. So you don't actually have any penalty for calling from Elixir to Erlang or from Erlang to Elixir. It's the very same thing. It's just the front end that you have to the language is a little bit different. So here's a highlight about protocol. So consider you have a JSON parser written by somebody else, and they just support a couple of types, say string, literals, integers, floats, and they just wrote a module that matches on the type of what you pass into the system, and they just produce a result. But what if you have your own type? Normally that would be a tuple with the tag that defines your own type. How would you extend this JSON encoder, in this case, to actually support your type? So there are a couple of ways to do this. You can pre-process your data structures before passing them over to the encoder, but that actually means you have to pass through your structure twice. So the first time you pass to convert your data structure to something this encoder understands, and then you pass it over to encoder. Obviously, it's slower, you allocate more memory. That's just not nice. The other one, you can fork that library and make a private copy of that library and extend it by basically writing your own additional clause for the encode function, which is not a great idea if you ever expect to integrate new developments in that library back into your project. So what does Elixir do? Protocols allow you to define that interface. So here you can see a JSON encoder interface that has a function called encode that just takes a piece of data, and it's actually a module that is generated out of this. And here we have just two implementations of it. They're using the defimpl macro, and they implement it for strings and integers in this case, just to keep it simple. So for every case, it defines the way to process that piece of data. And what JSON encoder module does, whenever it receives some piece of data, it dispatches it to a correct module based on the type of that piece of data that you passed to it. So if you decided that you actually want to support your own data type, that normally would be a record in Elixir, which is, again, pretty much the very same thing as in Erlang. So it's a tuple with a tag. You can add your own implementation, and then the JSON library can actually automatically start supporting your data type without you doing any extra work besides implementing this implementation of the protocol. Any questions so far? No? Good.
Yeah.
Oh.
What if you have like, well, I want to do my own string encoder. How does it know which one to choose from?
I mean, you can override the default encoder. Basically, whatever is the module that is loaded for that specific type, that's the implementation that's going to be used. Because it actually just looks at your type, it constructs a module name for that type. So in this case, it would be JSON encoder.string, the full name of the module. So if you overloaded it with your own implementation, that's what it's going to use, because it's dispatched by name. Make sense? Another one, standard library. So Obviously, a lot of people complain about Erlang library because it actually had to evolve for about, what, 20 years now, a little bit more than 20 years. Obviously, it has a little bit of crust and inconsistencies. And basically, we were in the best position to address this problem from our own perspective by creating our own standard library. And I will just highlight a few things like enumeration API, Dict, and a few others. So what's interesting about enumeration API, if you have a collection type of your own, it could be just about anything. If you can implement a very simple function that actually reduces through your collection and reduces the same thing as Foldle in Erlang. So you define something that just goes through every element and calls a function with an element and accumulator. The whole module of enum is available to your data type. So you can map, you can filter, you can do just about anything with any kind of collection that you have an implementation for. In this specific case, the file iterator function here, so it looks at etc password file. What it returns in this case, it actually returns a function. And that function just calls the standard reducer. So what this means is that this enum filter function, it just dispatches to the enumerable protocol, and there is an implementation for functions for the enumerable protocol, and it's able to apply this function to the collection of lines in etc password file. So here you can see that I'm filtering out comments out of etc password, and you can see a result there. It actually prints actual usernames and, well, the whole line with the password record. The other one, shell. So what we can do, we can define modules, we can explore type specs, and we can explore documentation without ever leaving shell. Here are some examples. So here we're asking for all types defined in the enum module, and you can see a T type that is defined through iterator. It's actually an old slide. It's now enumerable. Element and index, so they're just defined there, and then you can ask for, in this case, specifications for all variations of the sort function. So the first one will just sort an enumerable type, and the other one will be doing the same thing, but with the function passed to it, so a function that defines the order for your collection. So you can do that from the shell, as opposed to standard Erlang, where you pretty much have to go back to the source code to find the actual specification of the function that you're exploring. And you can do the same thing with this function by using h-helper. The h-helper will produce documentation. The reason why it's actually possible in Elixir is that every function that has a documentation, it actually gets that documentation embedded into the Beam file. So it's not just an HTML or any kind of other file sitting on the file system. It's actually right in your module, and you can request it very easily. And here's the example of that. So h-enum map prints the documentation for that function. Another highlight, Unicode. So I was showing a little bit of an example in the beginning of this talk. Basically, it's a really interesting case because it's a little bit over, it's actually a little bit over 200 lines of code, but it actually generates a file that is 250 or 60 kilobytes in size. So what it does, it reads the Unicode data and named sequence databases and just creates tons of clauses that will match every possible scenario. And that creates a very fast implementation that has no bottlenecks because it doesn't use any concurrency primitives. It's just an embedded database. So the status, yesterday 0.92 was released, and the community is growing. The amount of contributions has really exploded over the last month or so. We have 2 books coming out this year. They're already in beta. I think you can actually buy them even now in ebook format. And I think the actual books are slated for the release when we'll have 1.0. So they're coming out soon. And That's pretty much it, and I'll take questions. Any questions?
Is it possible to define functions in the shell?
Yeah, you can. Right now, the way it works, the shell is not an implicit module by itself, but you can define a module and a function. So we can actually go here. So let's see, def module m, and I would define a function, and then I'll just call it. So you can create the whole module without leaving shell and trying to compile a file, like you would do in Erlang shell.
Is there a macro expand facility in the shell as well?
Yeah, there is one. It's not recursive, so there's macro expand. So we can read documentation of that. It's pretty big. So the macro expand, unfortunately, it's not recursive, but it probably will be at some point. But so you can start actually expanding your macros and see what do they transform to.
Okay, cool,
Yeah.
cool.
Yes, Elixir seems nice to make a shorter syntax, to have some practical tricks in the shell.
Mm-hmm.
But does it bring new functionalities that is not directly ready to use in Erlang?
Mm-hmm.
That's the question.
How would you define additional functionality?
Something that is really much faster to do in Elixir compared to Erlang.
Faster as in programmers' productivity, or yeah, of course. Like here's an example that a lot of people like. So in we can actually even do an Erlang shell for that as well, I guess. So when you actually have to combine a lot of functions, for example, you want to process some data type and pass it through different functions, you would often write something as a simple example, like f of g of h of I, and then some data, right? So this way you can actually have to control where do you close your brackets, you know, whether you have the right number of arguments and everything. So it actually is very hard to read because you have to read from the center. So you have to find the center and go left and still be able to process arguments. So what we have to solve this problem is a string, it's a pipeline operator. So for example, I can do something like this. So I can have a value on the left and a function on the right. And basically what it does, it passes the value on the left as the first argument of the function on the right. And I can do things like this. So I can extend this construct and say string length. So you can actually see the whole pipeline of operation that you're going through, and this way you don't really have to endure all the complexity of reading this kind of code. So here you can really have the whole pipe. It's more of a syntax feature. The other.
Have you implemented Xargs?
Huh?
Have you implemented Xargs?
Implement-
Xargs. Have you implemented that?
Xox?
Xargs, the Unix thing where you then do wonderful stuff on the pipes.
Well, it is a pipe, right? So it's even called pipeline operator. So, so yeah, this thing. The other things, we have a pretty good file module that allows you to do a little bit more than Erlang. So you can do RMRF, you know, and all this kind of stuff. So it's actually just ready to be used without writing additional functions compared to the standard library. The enum module, again, it's a really great example of in addition to productivity. So for example, I was able to write implementations for enumerables for ETS, DETS tables, so that you can actually work with your tables in a lazy way, by processing, for example, with maps, filters, any, all, so you can actually apply that to any collection data structure. And that is very, very productive in my opinion. And protocols, I think it's one of the greatest things there because it actually allows you to swap out different implementations rather quickly. And I guess there's a lot of things that I don't remember off the top of my head, but some people find them useful.
You could just show, because I think the dict, for me that was like mind-blowing how easy it works with like key value stuff.
Mhm.
And you can, as you said, change the implementation, but just like getting the value of a dict, to me always I hate it that I have to do like case, and then 4 lines of code just to get a value of some properties or whatever.
Right.
And in Elixir it's like 1 line of
So you mean the hash dict or what?
So it doesn't matter because it's a protocol, but just
Yeah.
getting the value.
Yeah, well, you can create a new dictionary, for example, with some values, and you just use the dict protocol. It doesn't actually care what's inside. It could be a hash dict. It might be your own implementation, and then you would do something like this. It's quite possible to do that. And actually, yeah, I think it's a great example that hash dict is actually faster than other Erlang implementations of dictionaries. And what's even more important about it is all the implementations of dictionaries in Erlang, they have different APIs. So whenever you need to change from one dictionary format to the other one, it's really painful because the APIs are different, and it's really easy to make a mistake while converting from one data type to another one. And the beauty of HashDict itself is that it's actually adaptive to the size of your dictionary. So whenever it grows, it actually converts what's inside to a different, more appropriate format. No, it does not have include files. I personally think they're quite evil, but it does have inter-module dependencies. So the compiler can actually stop and wait until the other file is compiled. So it can require other module to be present before proceeding further with the compilation of the module that you're compiling right now. So the way it works, we have a parallel compiler, so it just starts multiple workers for a bunch of modules, and then whenever there's a dependency, it just waits for another one to finish the compilation of the other module, and it just does that. But there's no include, and I don't think it's anywhere in the pipeline to be implemented because it only creates problems.
Yeah, that's what I was hoping to say.
Thanks. Are there any restrictions in the Erlang VM which you are restricted by today? I mean, Elixir can probably move very fast-paced, but the VM won't. How does that affect the language and your future roadmap?
I think it's a nice blocker in a way, so it doesn't get us really crazy about things. So we still have to, have to sort of work around that. And if we just were able to change the VM, at our wish, we probably would change a lot of things and later regret those decisions. So that's sort of a limiting factor, the experience factor that is really great for us. With that in mind, we started opening up the conversation with the OTP team. How can we contribute to OTP in a way that suggestions or ideas or even patches, how to make it even a better VM. So it's going to be a slower process than it would have been if it was, say, a fork of Beam, and then we would just do something with it. But I think it's a great thing because this way we can throw ideas at and patches and get the best out of this integrated into Beam. I think it's only great for everybody because it's the only the only changes that I think will be integrated back into Beam are those that benefit both Elixir and Erlang, which is a great outcome for everybody.
Any more questions?
Do you have any examples of features that were just early in the history that seemed like a good idea at the time and then you rolled back on?
Yeah, there were a couple of, actually, a lot of ideas like that, especially in the very early ages of Elixir when I wasn't part of the core team. Basically, let me give an example. So we have what we call an access protocol. It allows you to use things like this. So you can define, and this is basically just a prop list. It's just a syntax trigger for a prop list. It allows you to do things like this. So you can actually refer to a key in that keyword list, how we call it, by using square brackets. Or if we use some record, like we have a file state record, so we can say, I think, for example, mode 100. So you can see, we can use, it's the same thing. It's actually implemented through protocols. But originally, this was also available to lists, so you could have done something like this. Now it's just not going to work. And basically, they were using that a lot, but then it was decided it's a bad idea. There are probably a few more that I just don't remember right now, but I definitely remember that even in the past year, we have dropped a lot of ideas. And at the same time, we took in many ideas from different languages that did show that they're really great. Like very recently, about a month ago or so, or two maybe, we added doc tests, just like in Python. And now actually the whole distribution has every example in the documentation tested automatically every time you build Elixir. So things like that, you know, they go into the language, and whatever proves to be a subpar idea, they eventually get thrown out. We're still pre 1.0, which does allow us to deprecate stuff quickly. We usually have 2 releases kind of cycle. So in one release we deprecate something, in the next one we just throw it away. And I'm not even talking about major-ish releases. I'm talking differences between 0.90 and 0.91. So that would be a deprecation cycle, and then in 0.92, that will be just thrown out. So it's a very short cycle, which we still have, you know, an opportunity to use before we go 1.0.
Anybody else?
There's a question there. Do they have an Emacs mode? Yes, there is an Emacs mode, Vim mode, Sublime, TextMate. I think that's about it. There. Can you build, sorry?
Can you bring it into your existing Erlang builds and work alongside? So you might have someone working on an Erl file and another part of it written in Elixir. And
So basically you're saying, for example, if you have an Erlang project?
yeah, I'm just thinking how to adopt it, if you brought it into a team, or would you have to go from we're writing in Erlang, we're now writing in Elixir, or can you kind of bring the two, can you bring it into an existing build? And I don't know.
Yeah, actually there was a change that we made about a year ago. It allows you to use Elixir as a rebar dependency. Then you only need to add one more line that will add Elixir libraries into the path, so you know the compiler can actually see them. And this way you can actually use the whole Elixir standard library from Erlang. For example, I think the most common case would be a string library, so that you have access to the Unicode functionality that we have. The other one would be a num library. I think it's a good example as well. And maybe a few more. For example, we have URI parsing, and Hashdict actually is another great example. If you just want to use this really great implementation, you can actually just integrate it into your project and use it. And I wrote a library called Xerl some time ago. What allows you to do, instead of writing the longer Elixir module name, because in Erlang they all look like Elixir dot something, so it would be Elixir Hashdict, Elixir string, and you actually have to put them in quotes because they contain dots. So that's rather inconvenient. So that Xerl library, what allows you to do, it allows you to generate a parse transform module from a very simple DSL. I think I should show this. There's a simple example of that. So Xerl. So here's an example. So you would write something like this. So really short code. I hope you can see this. So it defines an Erlang module and says it transforms any call to module called some module to this Elixir style module name. And then it will generate this transform module that you just include in your Erlang module. And then you can call this as if it was just a regular Erlang code, so it doesn't look Elixir-ish at all. Well, you know, after the compilation, you actually have the Elixir module name in there. But for programming convenience, you can just use that, and nobody even needs to know how it's actually called on the Elixir side. Anything else?
How does it look when you call OTP behaviors?
You mean from Elixir, right? Basically, what we have implementations for GenServer, for Supervisor, GenEvent. Just haven't had time for GenFSM. But basically, you would just say use GenServer behavior, for example, and what it does really, it just defines all the standard boilerplate for you, behind the scene. And this way, you can only override those functions that you actually use. So for example, if you don't write any handle casts or handle infos, why would you just write them? It's just you just define handle call and you're done. Basically, standard boilerplate should be generated automatically. It only makes sense. And the same, actually, the thing that I like even more is the implementation of the supervisor module. So I can never, like, after I actually started using Erlang in about 2001, and to this day, I cannot remember the order of arguments in child specifications. It's impossible. I just always copy paste them or use macros provided by rebar templates. But that module that we have, it allows you to basically use keyword lists. So something like you would say just module, my module function, my function. So they're actually named keywords. So you can use those to define your children specifications, and you can actually understand what's going on, and you don't need to consult with the documentation just to remember what was the freaking format for that. So yeah, I think that's, for me, it's even better than the GenServer part. Anything else?
Partial application.
So yeah, we have a little bit of partial application. So what you can do is things like this. So you can take an up map, and let's say we have 1, 2, 3 here in the list. So instead of writing something like x plus 1, and you can actually just write something like this. So it's not the full-blown thing, but it allows you to do very simple definitions of function. This is actually under another discussion cycle now, so we're trying to work out even a better format for this, because there's a lot of problems when you try to make something more complex with multiple arguments and multiple functions that you use in the very same call. Like if you'll do 1 and 2 and 3, it probably will compile to something that you did not intend it to be. And there are explanations to that, and with that in mind, it is considered that it's not very intuitive. That's why we're trying to improve on that. But it's just an ongoing discussion in the mainland list, so I don't know about the outcome yet. But that's pretty much it. I mean, this is probably the closest we get to partial application, as you know. Obviously, with the Erlang VM, we cannot go into more complex stuff when you can specify a function with just 2 arguments. You have to create a closure for that, basically, right? Just like in Erlang. So it's coming back to the question, how are we limited by the Beam VM? That's probably one of those cases where we are limited to the very same technique of creating new closure to do the real partial application of the function. Anything else? I guess we're done.
We're done. Well, we're a bit early, but
Yeah.
let's thank Yuri very much.